So now we have already performed the cross validation on the training dataset, and we have seen that the model is performing well on the training dataset. We have done the 5-fold cross validation and we got an accuracy of around 78.9. So now we would like to perform this model on the complete training dataset. We were doing 5-fold cross validation, but we will now perform the complete training dataset, take the training dataset and perform the logistic regression. We will once again define the logistic regression model like this. We will fit this model by using the dot fit x comma y, and once you write dot fit x comma y, the model has fitted on the training dataset. Now for the predicting, you use the model logistic dot predict function dot predict, and if you want to predict on the training dataset, then you write train and predictor bars. You get the predictions like this. Now if you want to predict for the test dataset, then you write here test. But for the test dataset, in this we don't have the survival variable, we can only give the predictions. But if you want to match that whether our predictions are matching with the actual ones, then for an example I am taking the case, but it doesn't make sense if you train on the same data and you also predict on the same data. But for the demonstration purpose, I am training on the training dataset and performing predictions on the training dataset and then matching it with the predictions and actuals to get the accuracy score, just for demonstration purpose. But you should always predict for the unknown dataset and then validate with the actual values. So let's predict, and then you have to import just one library. From sklearn, import metrics, and then you write metrics.accuracy score. So these are actual values train.survived, and these are the predictions which you already did here. So if you run this, you get 79% accuracy. Similarly, if you write train.survived, if you have that data set, then you can do this like this. But what you can do is, from the trained data set, you can make two parts. One is training data set and one is again testing data set. And then keep that training dataset part and train on that part only, and leave that testing dataset part and then validate on that. That set you can say as a validation set. So basically, before you had train and test when you download it, then what I'm saying is divide this train dataset into two parts: train df and validation df, and then only train on this part. Right now I just trained on this complete training dataset. We did the validation on this cross validation. What I'm saying is, now you perform the cross validation on only this and see the cross validation score, and then train the model on only train df instead of this complete data set, and then test on this validation df, because this validation df will also have the survived variable, and then you would be able to match the predictions with the actual values. So this is how the complete machine learning algorithm you can perform for anything: decision tree, logistic regression, random forest, or any algorithm. These are just the basic steps which you need to follow. I hope you have understood. Thanks for watching.